Hello, my physics lovelies. We're going to be going over example 2 from the energy unit today. Again, just practicing our skills with how to calculate the work being done by a force whenever we're looking at any system of objects or anything like that. Remember, every force does some amount of work on our system, so we can calculate that. We have, as shown in this diagram, we have a child applying a constant 20 Newton force. That's that force shown right there. Along the handle of this wagon, the angle is 25 degrees with the horizontal. How much work does the child do in moving the wagon a horizontal distance of 8 meters? So this is important because what this tells us is, let me change the size of this real quick. The wagon is moving to the right, But this force right here is going up at an angle of 25 degrees. So right away I know that there's an angle that we're going to have to worry about. There we go. Okay. When we're doing that, we're going to use the work equation. So remember, the equation for work can be found on our equation sheet. Right here we have the equation for work. Alright, this is the Work-Energy Theorem, which tells us that the amount of energy that changes in our system is what we call work. Okay, so our equation for work is right there, and we go back and we can use that equation to calculate the work done by the child. So work is equal to FD cosine theta, and this theta right here, that theta is the angle between the force and the distance that it's moving. So this theta is that 25 degrees because the child is exerting this force of 20 newtons, and the angle between that and the direction that this thing is moving is 25 degrees. So we're now going to plug all that stuff in. So we have work is equal to the force of 20 newtons. This thing moves 8 meters, and we have a cosine of 25 degrees. And let's see, plug all that stuff in, and we end up with work that is approximately 145 Newton meters. And we talked about units on the previous example. Remember, this is acceptable, a Newton meter, or its equivalent to 145 joules. Either one of those would be an acceptable unit for energy. Alright, so if you have any questions or want to see anything else, leave a comment or talk to me in class, and I will see you guys later.